Hello friends, welcome to pcgeokimberlite, my YouTube channel. Today we are going to study how you are going to identify the physical properties of the ore mineral. This is a practical number 4 as per the university syllabus of Savitribai Phule University, that is University of Pune, and now most of the universities has the same syllabus. Now for the FIBSc, this is the set of ore minerals, basically to know how these minerals have been studied and their properties have been found out by as per the each departments, whatever the specimens which are available, they can keep the specimen, but the total number which is there, that has been kept so that they can get the variety. So most of the important what we have, the ore minerals we can collect, so that every ore mineral from the various metals we can study. So I am Dr. Sajid Undekar, Associate Professor and Head, Department of Geology, Pune College Arts Commerce Science, CAM, Pune. So students have a lot of problems. First one, they take the late admission. So this is our practical number 4. Students are trying to get the admission in medical, they're going to get the engineering or allied branches, and ultimately what's happening, if their admission process go up to September, at the end of the September, and then if they could not get any branch, then they will take the job, so take the admission in the BSc. So most of the practicals have been over, so this is a very important practical, but they are going to miss out, that is the physical properties of the minerals, then quartz group, then non-quartz group, then ore minerals, and some crystallography practical also they are going to miss. So they are going to lose the whatever the 28, and what we have, the 6 marks will be there for ore minerals, so that they are going to miss it also. With keeping in this mind that they should cover up their syllabus, I'm preparing this video. Due to this COVID pandemic, we have been exposed to this particular arena, the visual classes. And similarly, with the help of this, I'm trying to make out how we can visually see practical also. This is one of the attempt I'm going to plan out. I don't have any mineral because due to pandemic, department is closed. I don't have any specimen now, but I am trying my level best to teach you this particular minerals and their properties and how they are calculated. Everything we have been done in the first video itself, that how to find out physical properties of the mineral. I'll just revise that also, then we'll go for the this ore minerals. Yes, we'll start with the ore minerals. The first mineral is pyrolusite. Now, these are the properties which you have to write, but there are other certain properties are there. There are the theoretical properties. Which are the theoretical one? Specific gravity, chemical composition, crystallographic system. Yes, these are the uses. Uses you have to write down for this particular ore mineral, but rest one non-mineral we don't have to write. These are the theoretical ones. These are not been expected in the practical. And the theory also, we are not going to ask these questions, but generally this is the in the practical is there. So you have to be very important one, that is color, streak, luster, form, cleavage, fracture, and hardness. Specific gravity, most of the ore minerals, they are the heavy one, that's why we are taken in the end. Earlier one in the quartz group of mineral we have seen all are the light one, then we have seen the non quartz group, they're a little bit medium one, we have some of them are the heavier one. Now this time we are going to have this next set of minerals which will be called as ore mineral, from where, from that ore we can extract the metals, maybe one, maybe two, maybe three metals we have been extracting. So these are been called as the ore mineral. And whenever a ore mineral is there, you have to write the uses. Half mark will kept for the uses. So no need to write one or two properties and left it out, because most of the students, they could not give the attention and they don't keep the interest. Whenever they come into the practical, most of the time they are talking or they are just writing. They most of the time they have been writing, and some whatever the work which is incomplete, whether it is botany, zoo, they will do it out. So they are going to lose their particular subject loss. I'm going to request with this video, students, focus it out. Hardly half an hour if you do it for practical, listen out whatever the instruction which is given for that particular practical, and after that if you do it half an hour, it is more than sufficient. You can easily understand. And geology is the subject in most of the colleges. It is not there in the 11th 12th. It is there in very few colleges it is there, and that's why BSc. So it is a new one. So most of them are being more casual one. They don't get the interest. If you don't show your interest, you are not going to learn anything. Say example, if you want a glass of water, if you're thirsty and if you want a glass of water, what will happen? You open the tap and put the glass, and what is happening within a few seconds, the glass will be fill out. But if I make the reverse, yes, I make the reverse this one and I open the tap, what happened? Till my death, the glass will not fill out. Yes, that is the very important. So your mind has to be open. So interest, anything is there. You can take a small child which will be 3 4 months is there. If mother is not he is not trying to have, take the food, then what is happening? Mobile will given, he gets the interest. He started playing now. So 6 7 8 months or 1 year to small child, they will know how to play games on the mobile because they have the interest. So any subject is there, you should show your interest so that you can get the easy one, and whatever the phobia is there, it will not going to happen. Maths probably the what we have the phobia because we are not given attention where it is having a problem. If that problem is solved, unnecessarily overburden, and that will be become his phobia, and he will be drop that subject. So you don't have to make out. Interest has to be there. Yes, focus is there. That is the very, very important one. And once you have the interest, very easy to learn it out. So now the first one, what we have, the mineral is Pyrolusite. Whatever you are going to see now, the mineral we have kept on this both the side. You can see the color will be little bit of black color. Streak is also going to get the black. Luster sub-metallic, you can see no shining is there, but it is like a metal, so it is a sub-metallic. Now most of, very important one here, most of this mineral showing you massive form. Every time wherever we are going to have, they are the crystalline, and but we are going to make out as a massive, the bigger mass is there. Cleavage is absent. Fracture can see now very clear, it is rough, uneven is there. Hardness 4 to 5.5 means with the key or coin, or if you rub the mineral on the striplet, you get a powder of this mineral, and the specific gravity is now can see 5. Earlier one we have seen up to 3.5, but this time you're going to see specific gravity. So focus it out. Most of the property, color, streak, luster, these are the three where you can get color, and most of the time the streak is also same. 1 or 2 minerals will be there, that will be different, and luster will be most of the time metallic or submetallic form. Everywhere it is a massive. Cleavage most of them time is absent. Fracture is uneven or even, that will be the most of the time uneven is there. And hardness you can make out about 4 to most of this up to 6, that will be their minerals. So now here this will be a chemical composition MnO2, manganese oxide. Crystallographic system is tetragonal, and important property is the color and the stick. Both are the black. So with this we can identify the pyrolusite. Most of the time the students are writing the numbers. Yes, these are the numbers which we have been registered to when we are going to make out the record of whatever the mineral which are there, the stock checking. So at that time it is required. So students remember the mineral or ore minerals with the help of this number. Don't make that mistake. See the property, try to find out, make the familiar with this. If you see any car which is going on the road, immediately will come to know whether it is the manufacturer, is who is the manufacturer, and what will be the model. Similar type, if you do it, if you show your interest, immediately you can get and learn it out. Familiar with, you have to be play, hold the middle in the hand, make out the properties 1 or 2 times, 3 times, and play with your friends. Show me what is the property, what is the property. Yes, this is the way. If you make out with your friends, within a few seconds we can remember the property. No need to by heart. Everything is there systematically. You have to go find out the properties. So this is what we have. The first metal is pyrolusite. Yes, the next one is a bauxite. It is the secondary mineral. So here some of the property we are not going to write it about. So here this what we have, it is a yellowish, reddish yellowish color is there, and it is particularly showing you the pisolitic structure. Yes, or vermiculars. That is the vesicles are there wherever, because it is in the heavy rain will be there, and it is the metal will be dissolved and carried out. The cavities will going to form the vermicular or pisolitic structure. Luster will be dull. Streak is brown. Reddish brown, reddish yellow. We say reddish brown. We are normally going to write about the what we have the laterite. Cleavage, because it is secondary mineral, we don't have to write cleavage, we don't write fracture, we don't write hardness. Remember now these three things: cleavage, fracture, and hardness. These things, once the mineral is secondary, we don't have to supposed to write this property. Specific gravity 2.25. See, very light one. Aluminum oxide is there. NH2O. Again, crystallographic system, secondary mineral, so it is not a crystallographic system. And with the help of the form, whether it is pisolitic or vermicular, we will find out the bauxite. There is a difference between the bauxite and the laterite. Bauxite is a light color, where it is reddish yellow color, and whereas the laterite is reddish brown color. This will go to the next mineral. Very important one. Chalcopyrite. Yes, earlier one we are not seen. Whatever we have bauxite, it is aluminum. Yes, and where we have the pyrolusite is Mn. So ore of Mn. We are just going to write where it is manufactured. No need. Just ore of Mn, ore of Al. Like that we have to write down. Chalcopyrite. This is a very important. It is ore of copper. Yes, you can see whenever you are going to see it is the or greenish golden yellowish color normally we can make out. So you can see very clearly here we can patch out. Yes, so that is there, or you can see here it is showing you the this color is a golden yellowish color is there. If you rub it out, somewhat gray or green color streak you're going to get it out. Luster will be the metallic one, massive form, cleavage indistinct. We can't see this cleavage. Fracture uneven. If you just rub the whole surface with your hand, we'll find out it is a gravity. Hardness will be 3.5 to 4. Slightly wherever you find a doubt is there, then that we have to make out with the C specific gravity. It is heavy 4.1 to 4.3. Chemical composition CuFeS2. Copper, iron, and sulfur. These three things are there. And crystallographic system is tetragonal, and distinguishing property is the golden yellow color. That is the very important. With this one property, we'll identify the mineral chalcopyrite, and it is a ore of copper and ore of iron. In addition, whichever the sample is there, like if you take out the sample, this chalcopyrite from the Singhbhum area or Mayurbhanj area in Bihar. Nowadays, it will be ground into the Jharkhand. So, in that number of other metals also we are extracting. Uranium is there, thorium is there. Then we have the silver, gold. So that also been calculated. So more than 2-3 metals we can extract from one sample. So that is a very important one. Chalcopyrite, from where the copper will be extracted, and with the in addition iron will be extracted. Next one is a graphite. The graphite is a carbon, and it is used in the electrical industry. Yes, so you can see the color. It is still gray color or grayish one. Yes, the similar, the color is also same and stick is also same. Yes, the gray, both will be the grayish one. Luster is a metallic one. Shining is like a metal. Now, very important one. That is the cleavage is not there. Form is massive. Again, see now. This is the fourth mineral where we are going to return the massive form. But just rub your thumb on the surface of the mineral, you will get the gray color. That is the hardness is 1. Sometimes if you don't get it out, scratch with this your nail, you get the powder. So it will be 1 or 2, but 1 normally you are going to get for the graphite mineral. Specific gravity is now low, 2.2 to 3. It is the carbon. Yes, chemical composition is a carbon. It is a hexagonal system, and the color and the luster, that will be the normal one, and the soft one is there within this ore middle. It is the softest one, so that will be become the graphite one. So it is the ore of carbon. Yes, similar color. It is the grayish, steel gray color. Yes, similar one, lead gray, steel gray, and if you have the similar one, gray color streak is also there. See now, shining is very important here. It is metallic shining. Here we have the granular form as well as the massive form. Both will be the form you can make out over there. Coarse crystals are there. So we can make out massive form. Cleavage we can't see. Fracture is uneven. Hardness 2.5 to 2.7. That means you're going to rub with your key or coin. You can get the powder of this mineral. Then see the specific gravity. It is a very heavy, 7.5 to 7.6. Galenite is a very heavy one. There is a PBS, lead sulfate, and cubic system is there, and color and luster. These are the distinction property or heavy spar. That will be the whatever the heavy spar in a non-metallic mineral is a barite. Now here we have the galena. They are the two heavy one. Both have the more or less same specimen from our department. Both have the same volume and both have the weight same. So both are the heavy spar are there. So this is the galena, and from here we have been extracting the lead. Yes, next very important one, the middle is magnetite. Again the color can steel gray or iron black, you can make out. Steel stick is also black. Sub-metallic, not shining as like what we have in the galena you're going to see. Again we are written the massive. Cleavage indistinct. Now see now, whatever mineral we have seen, in this the common properties, massive and indistinct. Fracture, uneven. Everywhere we have seen uneven. Hardness again you can see now in this again the common is there 5.5 to 6.5. Specific gravity again heavy 3.6 to 4. It is Fe3O4. O4 is the part will be there, cubic system, and distinct property is color, and the streak will be the distinguishing property, and the name of the mineral is magnetite, and ore of iron is the important property of this mineral. Magnetite just we are done. Hematite is a very important one mineral. Yes, hematite is an important mineral where color and streak are different. Yes, whatever you're going to see the color, it is a gray or yellowish, reddish color is there. But when you're going to rub on the mineral stick plate, you're going to get the cherry red, dark brown streak is there. Yes, that is a very interesting one. Steel gray is there, and cherry red is the important streak is there. So with this only streak cherry red, you can easily identify the mineral hematite. Luster is metallic, form is again massive we are writing. Cleavage absent, fracture uneven, specific gravity, hardness is 5.5 to 6.5. Yes, we are going to get the streak on the plate, so it will be a 5.5 to 6.5. Specific gravity 4.9 to 5.3. It is very heavy. Again Fe2O3. There Fe3O4. Here we have Fe2O3 is there. Hexagonal system, color and the streak. These are the distinction. Only color streak will be the distinction property. That is the hematite, and it is the ore of iron. Next one, very important one, chromite. Here, important one, granular form. With this one property, you can easily identify the chromite one. Color is a black. Streak is also black, sometimes brownish, but normally black. You are going to get it out. Sub-metallic, granular, and massive. Now, for first time here specifically, here we have a sample. We all three fine granular form. We have our chromite as well as we have coarse chromite grains are there. That also sample we have. So any one will be kept in the examination. So you have to prepare the both one. But here I taken as a granular, very small grains are there in that. Again cleavage indistinct, fracture is uneven, hardness again 5.5, specific gravity 4.1 to 4.9. About 3.5 whichever we have there, they are the heavy one. And the chemical composition FeOCr2O3. FeOCr2O3, and from here the chromium will be extracted as a ore So ore of chromium, that is a very important. Chromite, name itself, chromium, we're going to get it out. Cubic system and distinguishing property is the form. The granular form is the very important by which you can identify the chromite mineral. Come to the next one, silomelane. That is the last mineral what we are going to study here. So the important one, once you see the surface, you'll see a what? A bunch of grape. If you keep the bunch of grape, you will find out dome-like features. Or other one, keep the egg in a tray and bring in front of your eyes. Your dome-like features will be there. So similar thing when you are going to see any mineral or mineral surface, that mineral will be a silomelane. So here, this is the important property of this particular mineral is the form, botryoidal form. Color is a brownish or brownish black. Streak is also brown. Submetallic, botryoidal form. Cleavage absent. Fracture uneven. Hardness again 5 to 7. Specific gravity 3.3 to 3.7. MnO2 to H2O. And crystallographic system monoclinic. Form is the distinguishing property, that is the botryoidal form, and name is silomelane, ore of manganese. Now, when you make this conclusion, now there is a similarities. What similarities? That whatever the ore minerals are there, in that most of the time we are going to get color and streak are the same. That is the common one. Except the hematite, we have the different one. Next one, luster. Most of them are the submetallic, except one or two are there which are going to give you the metallic one. Form, everywhere we have written the massive. Only this silomelane is the botryoidal one, and chromite, which is a granular one. Rest one, we have the massive form. Next one, cleavage. Everywhere it is absent. Fracture, everywhere uneven. Hardness, most of the mineral are going to give you 5 or 5.5 to 7. That will be there. Specific gravity, everywhere we have the high. And very important one, you have to remember the chemical composition, because when you are going to write in the practical examination, you have to write down the chemical composition. For this, there is a mark is there, but crystallographic system, it is not required. Distinguishing characters are required, on which property you are going to identify this mineral. Identification is important. Don't write the name in the first. In the journal, we are normally write the name of the mineral on the top, then we'll write the property, so that we can learn and immediately come to know. But in the examination, on the basis of this property, you are going to identify the minerals. So the name should be written in the end, and the last one is the uses. What will be the use? Ore of Mn, ore of Fe, ore of Cu. Like that, you are going to make out the properties of this mineral. So this is what we have. Another set of minerals, that is the ore mineral. So here we complete all the practicals, right from the physical properties of the mineral. Then the next practical we have seen only the quartz group along with two mica minerals. One is muscovite and biotite. So total 12 minerals are there in the second practical. Again, in the third practical, we are taken around 15 to 18 specimen will be there of the non-quartz group, and this is another set is there of a ore mineral where we have around 10 to 12 minerals we are taken. So this will cover the FYBSc, the basic one. This is the basic how you're going to identify. When you're going to become a geologist, you should know the basics of the geology. That is, once you have the form that you can easily identify the properties, then it is a well and good. So these are the things where you have to give the concentration. Yes, then higher and higher. Nowadays, all UGC are changing. Already the education policy has been changed. Now the FY syllabus has also modified. SY now this year, from this year, SY also been modified. Next year TY is going to make out. So in the TY, whatever the basic subjects are there, that some of the subjects have been transferred to SY, and some of them have been eliminated and new topics have been added. So most of the basic, what as my opinion is there, whatever the syllabus is there of BSc first year, second year, third year, that will be the basic one. But nowadays, keeping into the mind the employability, university is added or UGC is added up, we can say the syllabus, advanced syllabus added. So where should we accommodate? So whatever the remaining part is there, that has to be transferred somewhere else. but now it has not been transferred. Whether we have in 11th and 12th the geology subject is there, then some part of the first year basic can be transferred, but that has been not transferred, so that will be a become. So in the future I may have a doubt that students can have the basic knowledge of the geology, the hell advanced one, but the basic, the foundation which is required, if this is not a proper has been given to the student, then it has become difficult one. So this is the where the minerals are to be thoroughly identified. Anytime if you just given a mineral, you can immediately start telling that this is a mineral property, these properties are there. You have to be on your opinion, you have to make out. Sometimes you may be correct, sometimes you may be wrong, but now whenever you go on mistake, you're going to learn so many things. I'm also made mistake, I have learned from my mistakes. So this is the way you're going to learn it out. If you don't make the mistake, then you're going to make havoc in the future. Anything is happening, you go into the psycho. Yes, that will be happening. So don't make that mistake. Whenever you are making the mistake, you are learning. You get the attempt to learn it out, and from the scratch you can start learning out. So this is a very important practicals are there. And hereafter we are already done the microscopy also. We are done properties between plain polarized light, then properties in cross. I made them the separate videos have been done. Now again I'm going to make out one by one a video on the mineral slides also of a FY BSc. Then I'll slowly go for SY practical, then TY practical. At the same time, I'm going to start making the videos on your theory also. So it will require a time. Now we are the free pandemic is there, but still we have to teach FY, SY, TY. Now it is going to start online, and soon good videos will upload on my pcgeokimberlite. PC is a Pune college, Geo is a geology, and Kimberlite is a source of diamond. I hope you like these videos, and thanks to visit and watch my channel. And if you like this videos, press the button like button, and share the video and subscribe my channel. Okay, thank you. Have a nice day.